Hello friends, this video on redox reaction part 5 is brought to you by examfear.com. No more fear from exam. Now let's talk about a new topic called oxidation number. As I told, the new definition of oxidation was increase in oxidation number. So what is oxidation number? See, the latest definition till now which we have learned is oxidation is nothing but loss of electron, right? Now with this reaction, if you see CH4 plus chlorine becomes CCl4 plus HCl. Now if I want to write CH4 becomes CCl4, whether it lost electron or gained, can you tell me? It's a little difficult, right? It's tricky because Na gave Na plus, pretty easy to take, right? Pretty easy. This guy, I'm not sure. I don't know. They need to think of the charge. So what can be the imaginary charge here and what can be the imaginary charge here? So if you find, you'll see that hydrogen is generally +1. So this is maybe C -4 charge. This becomes C. Chlorine is -1. This becomes +4 charge. And there is a loss of 8 electrons. Right? But for this you found this imaginary charge on the carbons. And that imaginary charge is oxidation number. Because, see, not all the reactions we can easily tell how many electrons it has lost or gained. So it's good if we can have this imaginary charge, and with that it's easy to compare. This is -4, this is 4, to 4 minus -4 is 8. So loss of 8 electrons. Just looking at this reaction, it's difficult to tell whether this reaction was oxidation or reduction, or whether it lost electron, gained electron, if lost how many, if gained how many electrons. So in that case it's good to have imaginary charge, and that is nothing but oxidation. Correct? So oxidation number, as I told, is imaginary, and the definition says it represents the degree of oxidation of element. If you don't understand this line, leave it. Oxidation is nothing but the imaginary charge on the atom. If the atom is broken down into ions, right, that imaginary charge that will appear on the atom if that particular element or the whole substance is broken down into ions. There's a difference between oxidation number and the formal charge. Oxidation number is the imaginary charge. For example, I have CH4. The imaginary charge on carbon is -4. I have H2O like this. The imaginary charge on hydrogen is +1, and oxygen is -2. But the real charge, for example, I have HSO4 minus. This is the real charge. This is imaginary charge. This is real charge. This really exists. For example, Na plus and Cl minus is the real charge. And fortunately, in this case, if you break, we'll get 1 and -1. So it is an imaginary charge, but it's a real charge. It's a real charge. But if you see water is a neutral molecule. But it is a imaginary charge on oxygen and hydrogen molecule. Also, if you want to understand the difference between oxidation and valency, you can see valency is nothing but the accommodating capacity of element. We have learned this in atoms chapter. In oxidation, as I told, is an imaginary charge. Please understand this as imaginary, which appears if the substance is broken into ions. And valency will always have positive values. Always positive value is the only number. But oxidation number can have positive and negative values. For example, in water, if you see, this guy is positive, this guy is negative. Valency is always whole number. Oxidation may be fractional. We'll take this in the later examples where we will see that we have fractional oxidation number. The valency is always constant, and the oxidation number can be varied. We'll see this also in the next two slides where we'll see, for example, chlorine has a valency -1, 2, 3, 4, like that. The carbon also, if you see in CH4, the carbon valency was oxidation number was -4. In CCl4, the carbon oxidation number is +4. So if you see in both the carbon, in one case the oxidation number is -4, the other case is +4, right? And obviously valency is the real stuff and oxidation number is the imaginary stuff, right? But oxidation number is pretty useful. We'll see that. An oxidation state and oxidation number almost linked. Oxidation number is nothing but oxidation state of the element in a compound. So I have an element in a compound like water, So all this element, hydrogen, oxygen element, you want to find oxidation state. This is -1, this is -1, this is -2. These are my oxidation number, right? Oxidation state of element. So I told oxidation number. Now the question that comes to your mind is, how do I get oxidation number? As I told in water, it was -1 and +2, but how did we arrive to the value? There has to be rules to find the oxidation number, and yes, of course, there are rules to find oxidation number, and we'll discuss those rules. The first rule says that in a free free state, each atoms bear oxidation number of 0. We'll discuss all these rules in detail. The second rule says that if it is ions, the oxidation number is equal to nothing but charge of ion. For example, I have Cl minus ion, so oxidation number is -1. I have HSO4 minus ion, so total oxidation state is -1, right? For this, if it is chlorine 2, the oxidation number is 0. Correct. The oxidation number of oxygen in most of the case is -2. There are exceptions to it, we'll discuss that. The oxidation number of hydrogen is most of the compound is +1. Again, there's exception to this, we'll discuss that. There is a oxidation number of fluorine is -1, and for other halogens it can vary. We'll discuss this in details. The algebraic sum of all the oxidation number is 0 for a given compound. For example, if I have in this case water, this is -1, this is -1, this is +2. If you add all, -1, -1 is -2, +2 is 0. So the algebraic sum of oxidation number of all the atoms in a compound must be 0. Also, if you are not able to find oxidation number using these rules, these are basic rules, what you can do is you can apply these rules also, but only if you are not able to find using these rules. So for alkali metals, it is generally 1 +1. For alkaline earth metals like calcium, magnesium, they are group 2. This is group 1. Group 1 is +1. Group 2 is +2. And for group 13 actually, it is +3. But generally with these information, you should be able to find oxidation number. We'll take a lot of examples. But before that, let me give you a memory tip to remember this. The memory tip is pretty simple. It says you have to remember this sentence: free ion of hydrogen hydrofluoride. Free ion of hydrofluorine. Please remember this: free ion of hydrofluorine. Correct? Free ion of hydrofluorine. Or let me give you a better one. I just thought of this: free image of human face. I think this is pretty easy to understand. Remember, right? Free image of human face. So free is what? F. So you just apply rule number 1. The next rule is I. I is ion. So the rule number 2 for the ions of O, oxygen. Oxygen will have a rule for that, and we'll discuss in detail. Human, H becomes hydrogen, and F becomes fluorine. So with this you'll remember all this. We'll discuss this free image of human face, right? Human face images are free. So free image of human face. I think with this you should be able to remember this. Remember this free image of human face. And there are some conclusions also for oxidation number. That is, most metallic elements have positive oxidation number, and non-metallic elements have negative oxidation number. We'll discuss this in the next few slides. So please be patient. And the highest oxidation number of a given element in a group is nothing but 10. Group number -10. We'll discuss these two in the detail. So we'll talk about the rule number 1. So the memory tip was free image of human face, right? So let's talk about the free part first. The free part says that in elements in free or uncombined state, each atoms bear oxidation number of 0. For example, if you see hydrogen, H2 oxidation number is 0, O2 oxidation number is 0, Cl2 oxidation number of each of the elements atom is 0, O3 is everything is 0, P4 0, S8 0, Na in free state is 0, Mg free state 0, aluminum free state 0. Free state oxidation number is 0. So if I am asked to find oxidation number of sodium in Na, it is 0. Oxygen in O2 is 0. In O3 it is 0. Magnesium in Mg it is 0. Hydrogen in H2 is 0. Right? Free state 0. First rule is done. The second rule says that it was free image of human face, right? So next is for ions. So for ions composed only of one atom, the oxidation number is equal to the charge on the ions. Please note, only for one atom. So for example, if you see Na plus, the oxidation state is +1. Mg plus 2, oxidation state is +2. Fe3 plus, oxidation state is 3. Cl minus, oxidation is -1. O2 minus, oxidation state is -2. Correct. Please remember, for Na, oxidation state is 0. For Na plus, oxidation state is +1. Similarly, if you have seen Cl2, oxidation state was 0. Cl minus, oxidation state become -1. Correct. So this is the second rule. Third is we have free image of human factor, right? O is oxygen. So it says the oxidation number of oxygen in most of the compound is -2. Please note, most, it is not all. Maybe 98% of the compound it is -2. But there are some exceptions to it. The exceptions are peroxides and superoxides, and also when hydrogen is bonded to fluorine. So let's take the first part. Peroxide, if you see H2O2 for example, or Na2O2, so in this case the oxidation state is -1. For superoxide, for if you see KO2, RbO2, in this case oxidation state is -1/2. So you have to remember this. It's very rare scenario. Peroxide is -1, superoxide is -1/2. Also when it is bonded with fluorine it is different. For example, if it is OF2, it is +2. If it is O2F2, it is +1. This is oxygen dichloride, and this is dioxygen, because 2 oxygen, dioxygen dichloride. Okay, 2 fluoride. So this is the exception. It comes in a very rare scenario. So if it is OF2, it will be +2. O2 it is +1. Right? So, and in case of peroxides, H2O2 and A2O2 like this, it is -1. And in case of superoxide, for example, KO2, RbO2, it is -1/2. Exception, but in most of the case it is -2. This is rule 4. Let's write the numerative once again. Free image of human face. H. As I told, so oxidation state of hydrogen in most of the compound is +1, except when it is bonded to metals. For example, if you see H2O, hydrogen will be +1. HCl +1. Right? CH4 +1. Correct? HF +1. H2SO4 is also +1. But when it is bonded to metal in minor compounds, for example LiH, NaH, CH2, here it is different. Here it is -1. Let's have the fifth rule. So I had the numerative was free image of human face. F, fluorine. So it says that fluorine will always have oxidation number of -1. Please note. But this is rule 5. It's not that you get the compound and you apply this rule first. This is the fifth rule. So you have to apply in the fifth stage, right? I will take one example where we'll say that fluorine has oxidation state of not -1. But this is the fifth rule. So which has to be applied. Okay. and other elements like chlorine, bromine, iodine, all the halogens, they may have oxidation number of -1 or -2, -7, +7, sorry, +6, +7. It can have any number, so it can have -1 also, but there is no guarantee on that, so we can just ignore this part also, right? So they can also have positive oxidation number, they can have negative, so we can even ignore these lines actually, because since we are not sure about the value, we ignore this line because we don't even know, right? So but fluorine has oxidation number of -1, but this is rule 5th. The 6th rule says that the algebraic sum of the oxidation number of all the atoms in a compound must be 0. For example, I have water molecules, right? This guy is -2, this is +1, this is +1. If you add all these, it becomes 0. It also says that for polyatomic ions where you have some charge, right, the algebraic sum for the oxidation number is nothing but the charge of the ion. For example, CO3 -2. Let's suppose I'll assume like this, it is minus. So if this guy is -2, -2, -2, this is +4. So if you add all this, it becomes -6 plus 4, that is -2, and that is nothing but the charge on the ions. And then I have special other rules which I'll use if I'm not able to solve the questions by the normal rules I have. So let's try to find the oxidation state for all the elements in this NaHSO4. So we have the rule of free image of human face, right? The first is the free, so it is for the free elements, but there is no free element here, so we can't use this. Next is for the ions like Cl2 ions or Cl- ions, F- ions. There is no ion here, so we can't use this. Next is for oxygen. So for oxygen I have oxidation number of -2. So let's put -2 here. And then I have for hydrogen. For hydrogen, it is told that most of the cases it is +1 except peroxide and superoxide. So this is +1 here. So for hydrogen, I got +1. Then I am left with sodium and sulfur, right? So sodium and sulfur, all the hydrogen, this rule is gone. Fluorine, there is no fluorine here. And I'm yet to get the value of sodium and sulfur. I can keep at the max 1 is X. Then I can use the last rule which says that sum of oxidation state is 0, right? So here I have two unknowns, sodium and sulfur. So what should we do? We'll use this rule now. Alkali metals have +1 oxidation state. So which is the alkali metal here? Sodium. So this is +1 here. So sodium is +1, and then sulfur I can assume as X, right? Because 1 I can assume as X, and then I can use the last rule. It becomes sodium, that is 1, plus hydrogen, that is 1, plus sulfur, that is X, plus oxygen 4 into, that is -2, and total is nothing but 0, right? So if you solve this, you get sulfur as X as 6. So the sulfur atomic oxidation state is 6. Let's check this guy. K2MnO4, same thing. The free element rule we can't apply, it's not free element. Ion rule we can't apply, it's not ion. Oxygen is -2. So let's put -2 here. Then hydrogen, there is no hydrogen. Fluorine, there is no fluorine. And then I have two unknowns. So I'll use this rule. Alkali metal 1. This I'll use at 1. And this is X. So this becomes K is +1. So let's solve this. This becomes 2 into K, that is 2 into +1. Mn is X plus 4 into -2 is equal to 0. You solve, you get X equal to +6. Right? So here Mn is +6. Similarly, AlH4, let's apply. Free rule we can't apply, it's not free element. Ion rule we can't apply, it's not ion. Oxygen, there is no oxygen, we can't apply. LiAlH4, right? So H becomes +1. So +1. Then fluorine we can't apply. Then I have two unknowns. Then I will apply this rule. Alkali metals have +1 oxidation state. So alkali is Li. So Li is also +1. And Al is, we'll assume X. You apply the last rule now. So that is nothing but hydrogen, lithium is 1 plus aluminum is X plus hydrogen is 4 into +1 is equal to 0. We solve this, X nothing but -5. So aluminum is -5. Correct. But is this correct? Do you think aluminum is -5? There's something wrong here. Correct. Let's revisit things. Fluorine, F free rule we can't apply. Iron rule we can't apply. Oxygen, there is no oxygen. Hydrogen, remember there were some exceptions. In case of hydrides, it was -1, not +1. Correct? This is not +1, this is -1. And for lithium it is +1, correct? So now if you apply, now if you see, X comes out to be +3. And that looks correct for aluminum, because aluminum, Al +3 you must have seen a lot of places, right? This is correct. So this was I did intentionally just to show you that you should not forget that hydrogen has exceptions, oxygen has exceptions. So here hydrides, it is -1. Let's take this scenario where we have to assume the alkaline metals of class 2. ZnCO3, same rule I will apply, that is free image of human face. Free I can't apply, it's not free element. Ions I can apply, it's not ion. Oxygen I can apply, oxygen is -2. This is -2. Hydrogen I can't apply, there is no hydrogen. Fluorine I can't apply. So I have two unknowns, zinc and carbon. What will you do? Then we'll use this. So zinc will become +2. Right? This is +2. And carbon is X. So we'll solve this. Zinc is +2. Carbon is X. Plus 3 into -2 is equal to total sum is 0. Total sum rule. So with this, you get X as 4. So carbon has oxidation state of class 4. Correct. Let's take the scenario where we apply this +3 rule. The group element group 13 has the +3 oxidation state. KAlSO4 2. Here let's apply the same thing. Free image of human face. Free we can't use, it's not a free element. Iron we can't use. Oxygen we can use. This is -2. Oxygen is -2. H hydrogen, there is no hydrogen, there is no fluorine. So I have sulfur, aluminum, potassium. 3 unknowns. So in this order, the first one was for group 1. Group 1, it is calcium, K. So K is +1. And then we have to apply for group 2, there is no group element. Then group 3, we have aluminum, +3. And sulfur I can assume as X. So if you solve this, you get K is +1 plus aluminum is +3 plus S is 2S, that is 2X. Oxygen is 8, 4 into 2 into -2, total is 0. If you solve this, you get 2X is equal to 16 minus 4, that is 12. X comes out to be 6. So this guy is 6. Correct? So we have to apply always in the order. So if this is not if you are not able to get the value from this, then you have to apply group 1 first, then group 2 first, then group 13 first. Right? In that order. So let's take the common oxidation states chart. For example, for hydrogen, the common oxidation state is -1 and +1. For helium, it's 0, it's noble gas. For lithium, it's +1. B is +1, +2. Boron is 1, 2, 3. Carbon, if you see, +1, +2, +3, +4, -1, -2, -3, -4. All experimented values. Nitrogen, +1 to +5 and -1 to -3. Oxygen, +1, +2. Also -1, -2. Fluorine is all most of the case -1. There are scenarios where you get +1 also. I can show you one example, but very rare. Neon 0. sodium +1 or -1, magnesium +1 +2, aluminum +1 +2 +3. So if you see, there is something dark here, right? That means in most of the case it is +1, here it is +2, here it is +3, here it is most of the case it is +4, in fact here it is +5 most of the case. Oxygen is most of the case -2, fluorine is -1 most of the case, sodium is +1 most of the case, magnesium is +2 most of the case, aluminum is +3 most of the case, but it can have +1, +2 and +3. Similarly, if you see for more, phosphorus can have +1, 2, 3, 4, 5 most of the case, also -1, -2, -3. Sulfur can have +1, 2, 3, 4, 5, 6, -1, -2 also. Chlorine can have -1, 2, +7. Most of the case we have these. In sulfur you have these. Similarly, argon there is 0. For potassium, most of the case is +1, but we have -1 also. Calcium +1, +2, +2 mostly. Similarly, we have the list. You don't have to memorize this, but it's good to see this list once so that you can get comfortable with the oxidation states of various elements. All experiment. So there were two conclusions also we had drawn for rules to determine the oxidation number, right? The first one was the metallic elements have positive oxidation number and non-metallic has positive or negative oxidation numbers. This is something which we can see from the table also. Now we'll take some examples. We have three elements CS, Ne and I and F. Here to find the element that exhibits only negative oxidation state. Also the one that exhibits only positive oxidation state, the one that exhibits both positive and negative, and the one which is neither negative nor positive, right? All these things you have to say. So for negative, if you see, fluorine is the one which has negative always. Positive, if you see, my CS is the one which is always positive, right? Positive and negative, if you see, iodine, if you see, it has -1, +1, +3, just the last table which you saw. And neither positive nor negative, that is the neon, the inert gas. This is my answer. So we can tell this answer from the table, the last table which we have studied. And the conclusion too was that the highest oxidation state, the highest oxidation number of an element in a given group is nothing but the group number -10. For example, if you see, for group 1, the highest number is +1. It can have -1 also, but the highest is +1. For magnesium, the highest number was +2. It can have -1 also, but +1 also, but highest is +2. For aluminum, you see, is group 13. 13 -10 is 3, right? And this is for all the groups greater than 10. For group 1 and 2, it's just the group number actually. It's 13, right? So it can have +1, +2, and +3. But the highest is +3. Similarly, for silicon, it can have +1, +2, +3, +4, but the highest is +4. Similarly, for phosphorus, the highest is +5, for 6, +6, and for this +7. So please note, the highest word is critical here. The highest number is something that is the group number -10. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.